let's solve this problem. Search in a sorted array of unknown size. Okay. Let's check out this problem. So given an integer array sorted in ascending order, so this array is sorted, okay? Write a function to search target in numbers. If target exists, then return is index, otherwise return -1. However, notice here, however, the array size is unknown to you. So you may only access the array using an array reader interface where the array reader get k returns the element of the array at index k. So here is a 0, start from 0, index it. Okay, so you may assume all integer in the array are less than this much. And if you access the array out of bound, and then the array reader get will return this very large number. Okay, here's the example. The input of the array is this much, and we are searching the target none. Okay, so if none exists in this array, then we return the index of none is 4, 0, 1, 2, 3, 4. Okay. Okay, so in this question, when we think about this question, okay, we can actually have a many solutions. So if we just like a search like a on to just like a search like a iterator, write a loop iterator start from 0, 1, 2, 3, 4, and then but there's gonna have a problem because the array size is unknown. That means that your loop will end up infinity. Okay, so and then because this array is sorted. So we may think about binary search, but because when we do binary search, we need to know about the upper bound. Okay, so but this one because it's unknown, so we need to know the upper bound of the binary search. But because this problem, okay, binary search, because this problem we don't know the size, so that's gonna be a problem. But yeah, how to solve this problem? How to solve this problem? Okay, so to solve this problem, so we have two steps. Okay, so first, so what are we gonna do? Okay, let's do this way. So first, we need to get the range. Get the range. The range means that the target in any range of the array, right? In the left portion, right portion, or somewhere, right? So first we need to get the range. Once we get the range, we can actually do a binary search. We can actually do binary search in the certain array, right? So because this problem, the array size is unknown. So the first we get the range. How do we get the range? Let's get this example. So let's say we don't use this example because this example pretty much is simple. Let's get a larger size. Okay. So okay, let's start. Let's say this 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 array is like this, okay, okay, it's very very large one. Okay, let's say the very very large one. Oh, oh, sorry, let's do 8,000. 8,000, let's give the example 8,000. Okay, so the index of the this array, this 0, 1, the 2, 3, 4, 5, 6. Okay. 6, maybe 12, maybe 24, 48, maybe 2000 somewhere, or maybe 4000. Okay, so this is the index of the array. So what are we gonna do? Because we don't know exactly like the size of the array. So let's do that. Let's initiate. This is the left, and this one is right. Okay, this is initiate. So what are we gonna do here? So, we actually try to get the so we have the array reader get the k. We make the right equals to k. So we get the right, the value of the right, and then in this case we get it a 1. No, we get it a 3. So what we're gonna do, we will check this value if smaller or greater than the target. So if smaller than the target, no, if greater than the target, okay? Yeah, if smaller than the target, sorry about that. So because this doesn't study, so I want to give you an example like, so if this value is smaller than the target, then we just double R, so double the size of the array, the searching array. So here now is 1, and then it will become 2. Okay, so it will become this one, and then we check again the value. If it's still smaller than the target, then we double the size again. We double kind of like a okay, we double the size. So basically what are we doing? We actually doing R equals to double R, the index. So we are kind of searching the range until if we found let's say, okay, and then the R is here. And then when we check this value, I mean the index is R, the value of the index, if greater than the target, that means that that means our target actually is in the range of here. Okay, so this basically this algorithm. And then after we found the range of the target, and then the second step we will do the binary search. So basically, let's see. When we try to get the range, the term complexity is log n. Log n, right? And then the binary search, we are trying to actually find the target between that range. And then the time complexity of this part is also log n. So that means the time complexity for this problem is gonna be 2 log n, 2 big O log n, and then it will equals to log n. Okay, so let's write the code. Okay, first we're gonna initiate. We're gonna int left equals to 0, and then the right equals to 1, and then start from here, right? The left, this is the right. Okay, and then we have a while loop. The while loop, we have a reader dot get element k, right? So here we get a right. Okay, so if this right smaller than target, if smaller than target, that means that the target actually is bigger than the R, is in right portion of the R, right? So the right side of the R. So if less than, then what we do, we just write equals to 2. Okay, yeah. just like this. We just double until we found it. Until we found the element of right is smaller or equals to the target. That means it's in this side. Okay. And then we do the binary search. The binary search, what we do, left plus 1 smaller than right. And this very classic binary search. So first we define the middle. We define the middle because we have left pointer, right pointer, and a middle pointer. And then we write it this way because we want to avoid the overflow. So we write it this way. Okay. Also, we need to get the value of, because this question we have the array reader.get. We need to get the value of the middle from the array reader. So what do we do? Okay, so what we do reader dot get middle of the value, and then we check. So we're gonna check our value if greater or equals to target. So if our value is greater or equals to the target, that means our value is inside the range. So what we're gonna do, we're gonna update the right pointer. We're gonna do equals to this. Otherwise, we will update the left pointer. Okay. This is a while loop. So after while loop, we need to do post processing. Remember the binary search. We have three. We have three. Three section. We can say three section, or so pre-processing. Pre-processing is a sort. So if unsorted, we need to sort it. Okay, so in this case, it's already sorted, and then we do binary search, and then we're gonna do post processing. Post processing is to trying to check the this what we're gonna do. So we're gonna do the post processing. After we do this, we check if the reader dot get left equals to target. If it equals to target, then we just return the left, or we just return the reader dot get right. If this one equals to target, if right equals to target, then we return the right, or we just return -1. That means we cannot find anything in this array. Okay, let's run the code. Let's see this code if it's runnable or not. Okay, code accept. Okay, let's submit. Okay, works. Okay, thank you for the watching. I'll see you next time.